Hello guys, welcome to the first video of machine learning. Well, machine learning is now at the heart of much of the magic in today's high-tech products, ranking Google search, recommending videos and songs, and even beating the world champion at the game of Go. Before you know it, it will be driving your car. So naturally, we are all excited about machine learning and would love to join the party. So let's start. Well, a lot of the upcoming videos will be based on this book, Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. So please get your hands on this book if you can. Otherwise, I'll be sharing the contents of this video on Innovators Digest website, so you can download from there as well. Now, what is machine learning? Well, machine learning is the field of study that gives computers the ability to learn without explicitly program. For example, as you can see from this image, without machine learning, we need to give computers very specific instructions. But with the machine learning, we only need to feed computers with lots of data, and it will be able to learn from the training data that we provide and use it to train machine learning algorithm to perform its task and to predict the outcome that we want. Well, performance measure will then be carried out to evaluate the performance of the machine learning algorithm. There are mainly three types of machine learning: supervised, unsupervised, and reinforcement learning. In supervised learning, the training data you feed to the algorithm includes the desired solutions called label. For example, the input data is apple, and we need to label it as apples. So the model will learn from this training data, and when we give the model a new data, for example, an apple, it can predict that it's an apple. So when we provide it with new data, it's able to predict the correct outcome. There are mainly two types of supervised machine learning: regression and classification. Regression is used to predict numeric values such as temperature or the price of a car or price of housing when given a set of features which are the predictors. Linear regression is a type of regression, and the line on the graph is the y equals to mx plus c, so we can predict the y value from x. Whereas classification is to classify data into categories. For example, whether it will be hot or cold tomorrow, and it's not numeric data. Here are some of the examples of supervised learning: decision trees, random forest, KNN, linear regression, logistic regression, SVMs, and neural networks. These are some of the most common examples of machine learning algorithms. Next, we will be talking about unsupervised machine learning. Well, in unsupervised learning, as you might guess, the training data is unlabeled. The system tries to learn without a teacher and groups similar data points into different categories, or we call it clusters. So in unsupervised learning, there's no labeled data, so it's mainly categorizing similar data into different groups or clusters. So it can clusters the bananas into one group and the apples into another group. These are some of the examples of unsupervised learning. For clusterings, there are K-means, DBSCAN, and hierarchical cluster analysis. For example, say you have a lot of data about your blog's visitors. You may want to run a clustering algorithm to try to detect groups of similar visitors. At no point do you tell the algorithms which group a visitor belongs to, but it finds those connections without your help. For example, it might notice that 40% of your visitors are males who love comic books and generally read your blog in the evening, while 20% of your visitors are young sci-fi lovers who visit during the weekends. and so on. If you use a hierarchical clustering algorithm, it may also subdivide each group into smaller groups, and this may help you to target your posts for each group. Visualization algorithms are also good examples of unsupervised learning algorithms. You feed them a lot of complex and unlabeled data, and they output a 2D or 3D representation of your data that can easily be plotted. For example, this is the TSNE algorithm, and it's a visualization algorithm. Next, let's talk about reinforcement learning. Well, reinforcement learning is a very different beast. It learns by itself. The learning system, called an agent in this context, can observe the environment, select and perform actions, and get rewards in return or penalties in the form of negative rewards. It must then learn by itself what is the best strategy to get the most reward over time. For example, many robots implement reinforcement learning algorithms to learn how to walk. DeepMind's AlphaGo program is also a good example of reinforcement learning. It made the headlines in May 2017 when it beat the world champion Ke Jie at the game of Go. During the game, AlphaGo was just applying the policy that it learned. Now, here are some of the challenges of machine learning. Machine learning requires a lot of training data for it to perform well. For example, for a toddler to learn what an apple is, all it takes is for you to point to an apple and say, apple. Now, the child is able to recognize apples in all sorts of colors and shapes. Genius! Well, machine learning is not quite there yet. It takes a lot of data for most machine learning algorithms to work properly. Even for very simple problems, you typically need thousands of examples. And for complex problems such as image or speech recognition, you may need millions of examples. Next, non-representative training data. Well, it is crucial to use a training set that is representative of the cases you want to generalize to. This is often harder than it sounds. If the sample is too small, you will have sampling noise. But even very large samples can be non-representative if the sampling method is flawed, and this is called sampling bias. Poor quality data. Obviously, if your training data is full of errors, outliers, and noise, it will make it harder for the system to detect the underlying patterns. So, your system is less likely to perform well. It is often well worth the effort to spend time cleaning up your data. The truth is, most data scientists spend a significant part of their time doing just that, cleaning data. Irrelevant features. Well, as the saying goes, garbage in, garbage out. Your system will only be capable of learning if the training data contains enough relevant features and not too many of irrelevant ones. A critical part of the success of a machine learning project is coming up with a good set of features to train on. This process, called feature engineering, involves feature selection, feature extraction, and creating new features by gathering new data. Next, let's talk about overfitting and underfitting issues in machine learning algorithms. Say you are visiting a foreign country and the taxi driver rips you off. You might be tempted to say that all taxi drivers in that country are thieves. Overgeneralizing is something that we humans do all too often. And unfortunately, machines can fall into the same trap if we are not careful. In machine learning, this is called overfitting. It means that the model performs well on the training data, but it does not generalize well. It will not perform well in test data and new data, resulting in bad prediction. As you might guess, underfitting is the opposite of overfitting. It occurs when your model is too simple to learn the underlying structure of the data. If you're interested in the contents of this video, I'll be uploading the slides and the contents to the Innovators Digest.wordpress.com, so please go there and download them if you wish to. So that's all for today's video. Thank you so much for watching, and I'll see you in the next video.